Hello everyone, and welcome to the fifth and final video lecture recording for our Class 11 time series of videos. So in this video I wanted to briefly go over some last parting thoughts about some Fisher projections and then also cyclic stereoisomers. So let's consider the stereoisomers of 2,3,4 trichloropentane first. So we have this particular stereoisomer drawn in Fisher projection. It's easy to see that there is a horizontal internal plane of symmetry cutting across the middle carbon, C3, the chlorine and the hydrogen bonded to C3 and reflecting the top to the bottom. So we know that stereoisomer A is achiral, and it's meso because it has two stereocenters. How about stereoisomer B? It also has a internal plane of symmetry cutting across carbon 3. It is also achiral or meso. And strange as it may seem, B is not identical to A. There's no way you could superimpose all of the atoms on it. However, they are molecules that do share the same number and type of atoms with the same type of connectivity, so they are stereoisomers. They're not related as mirror images, so A and B must necessarily be diastereomers. How about stereoisomer C? Well, this is an SS configuration, and interestingly enough, it doesn't matter if you switch the hydrogen and the chlorine on this middle carbon, which is not a stereocenter. That SS stereoisomer will still be the non-superimposable mirror image of stereoisomer D, and you could play around with that with your model sets if you bought them. But anyways, you can see quite clearly that stereoisomer C is mirror image of D because the Fisher projections are right next to each other, and it's as though there is a mirror plane between stereoisomers C and D. They are both chiral. There are no internal planes of symmetry. So as I mentioned, C3, the carbon number 3 in all stereoisomers of 2,3,4 trichloropentane is not a stereocenter. How are A and B related? Well, they are diastereomers, as I said, and then of course C and D are non-superimposable mirror images, so they are related as enantiomers. So, one last idea for this video. A little bit more about cyclic stereoisomers. Let's look at 1,2-dimethyl cyclobutane and its stereoisomers. Well, we could have the RS stereoisomer A, and here you can probably see that there is an internal plane of symmetry, so we know that A is achiral, and more specifically it's meso. It possesses two stereocenters and its mirror image would be identical. How about stereoisomer B, the SS isomer of 1,2-dimethyl cyclobutane? Well, this is chiral. You could also look at its mirror image, the RR stereoisomer, and you would indeed not be able to rotate this in any way, shape, or form where you could make it superimpose for all the groups on B. So B and C are related as enantiomers, and as I mentioned in a prior video, cis and trans cyclic stereoisomers are diastereomers. So this stereoisomer A, which has the methyl groups on the same side of the plane formed by the four-membered ring, so they are cis, would be a diastereomer of either B or C, where those methyl groups are trans. So that's a good review there. How about 1,3-dimethyl cyclobutane? Both of these isomers are achiral. They're not meso, there are no stereocenters. What about 1,3-dimethyl cyclohexane? Now we have, these are related as diastereomers, cis and trans stereoisomers or cyclic diastereomers. The RR is chiral. Of course, it has a non-superimposable mirror image, which would be the SS 1,3-dimethyl cyclohexane. This RS is achiral. It's meso. You can see there is a mirror plane that cuts diagonally through the molecule where my pen is pointing. So that completes our series of video lectures for the 11th class time session. I will see you guys in class.